Hello everyone and welcome to today's video where we'll be talking about Kubernetes. Kubernetes, also in short K8. First of all, what is Kubernetes? In simple terms, it is a orchestration tool for containers. Now, if you have seen my last video, you have seen that I have talked about Docker, or if you know about Docker, it will be really helpful because it is a prerequisite in learning Kubernetes. Kubernetes, as you can see, as I've written, orchestrates containers, and by containers, you can guess Docker. There are other tools, containerization tools, but Docker is the most familiar and most widely used one. Okay, so we get what is container. What is this part that orchestrates? Orchestration. Well, by this we mean managing, or you can say uh, supervising. What we are doing is that in Kubernetes we deal with lots of containers. Containers, it can be Docker or other containers, but mostly Docker, and we manage all of those with this tool called Kubernetes, or in short K8. Clear? This is the basic definition or a vague idea. Clear? Okay. Now if you have forgotten what is a container, let me just give you a brief summary. Suppose this is your device number 1 and this is your device, or say machine. This is a laptop, this is also a laptop. This runs on Windows, this runs on Linux. Container, here Docker, is such a tool that allows you to run an application by Dockerizing it. It is called containerizing. You put the app inside a container. Let me show you. Suppose this is app, it is outside now, and what you do, you put it inside a Docker container, and when you do that, regardless of your operating system, this app will run on Windows and also in Linux. Okay, this is a brief idea of Docker. And what we are saying is that Kubernetes is a tool that deals with thousands of these type of containers. Okay? Okay. Now, the question is, why? Why do we need this tool called Kubernetes in the first place? Well, the answer to that is that the Docker that we are telling about has some constraints, or you can say some lackings, or you can say some problems. Due to those, it was a must to introduce something called Kubernetes, or have something of this type of tool that will manage or solve these problems. This is why we need Kubernetes. Now let's discuss what problems or constraints or lackings that does Docker have that that forced us in creating or developing a tool like Kubernetes. Okay, let's go there. First problem with Docker, you can say host management. Management, if I'm not wrong with the spelling, I guess there should be an E. Pardon me if it is wrong. Host management. What do I mean by that? This is a Docker container, right? Okay. Suppose you have multiple containers. Let me put them side by side. Let me try it. Wait, just give me a moment. Yes. Okay. Okay, fine. This is the containers. Another one. Yes, I got it now. Suppose that you have a machine. Okay, you have a computer, laptop, or anything. Okay, and you have these 4 containers. Fine. Now you are running them simultaneously, but unfortunately you have 12 GBs of storage, but unfortunately the first container here is taking 10 GBs of the storage capacity. Okay, the next one is taking 1 GB and the other one is also taking 1 GB. So up to the third one, your full capacity, okay, is now fulfilled. You don't have any other spaces left. That's why the fourth container that you see here, it won't even start. Okay, it won't even start. Or if it has started, after some time, due to the lack of storage, since the whole 12 GB is already filled up, it will die. Eventually this container will die, and everything, every resource, every part of the application related to this container won't work as well. So it is a major issue, right? You can just forget about this container. Okay, the containers not need to be uh, dependent on each one. Just because of your size or capacity restrictions and not able to handle the resources, one of the major components of your entire system is just getting cancelled. This is host resource management. Okay, there would be a resource here, host resource management. So this is a problem with Docker, that it does not allow you to uh, manage resources that effectively. Here I have just showing you 4 containers, but in real life it can be 100, it can be thousands of containers. So if this issue happens, just imagine if you are running a big enterprise or big company, then there will be chaos. Your entire system might fail. Okay, so this is the first problem. Another thing that can happen, that is the problem of scaling. Now what do I mean by scaling? Let's grab one of the Dockers here, Docker containers. Okay, okay, fine. Now here we have one Docker container, right? Let's bring another one. Grabbing one of those is the main problem. Okay, it came up nicely. Let's pick another one. Okay, fine. Yeah, good. Now inside your system you have 3 containers. Okay, and you have engineered them to take the load of 5,000 requests. Okay, now suppose that you have a company and it has just got really famous. Everyone is going to your website and ordering them, and in a holiday, due to the discount, the request rate, the number of requests just got tripled to 15K. But the system that you have here can't support. It only manages 5K requests, right? So in this case, you need manual intervention. You need an engineer who will manually give effort and make another Docker container here, right? Then configure everything, then handle this one, right? To handle this huge amount of requests. So due to this, it is time consuming. You have to do it manually. Also, in some cases, it costs you. Okay, so it is a big no. Okay, the whole thing of scaling, that you need another container, but you do it in a really, really hard way. It is so complex. The same thing goes for opposite. Like, I can manage 5K requests, but all of a sudden the requests are really, really little, small in number, like let's say 1K. You don't need these 3 containers to manage 1K requests. So if you still run the 3 containers, it is a waste of money, okay, waste of resource, and it is again a complete loss. So again, if you want to manually remove your container, you need to do manual work to delete this one and also this one. You will be needing manual work, an engineer. It will cost your time, it will cost your money. So it is again a big problem. Okay? So this was our second problem. First, we discussed about the host resource management and then the scaling one. Another problem that Docker can't face is something called load distribution. Load distribution. Again, let's call in a Docker. Suppose this is our container. This is our another container. Let's bring in a third one. Third container. Now, you are getting requests. You are getting requests for your system, and since you are not using Kubernetes or any other tool, you are just hosting the containers, Docker containers. It is getting distributed randomly, and this might happen that this container deals with the 70% of the requests, whereas this deals with only 20% and this only with 10% among all the requests. What will this mean? This will mean that this container that you see will get slow, will be inefficient, and it might even die if any major issue comes up, or any other issue may also arise. So it is also a big problem since the workload is not getting divided in a good manner. It is 70, 20, 10. So huge pressure on the second container. So load distribution is a huge problem when we are talking about production grade enterprise level systems where we have tens and thousands of containers like this. If we don't divide the workload equally or in a good way, containers might fail, or the overall output would be really bad, inefficient, and it's also a major problem. Okay, so this was our problem number 3 that can happen due to Docker. Okay, if we just do Docker containers. Okay, another thing that can happen, that is problematic containers. Suppose again, let's bring in our containers here. Wait. Oh, yeah. This is our container number 1. Let's bring it another one, and another one. These are our three containers. Now, suppose these are connected, they can be connected or might not be connected. Like in Docker Compose, if you have idea of Docker Compose, what it basically does is that it combines the Docker containers into one application. So these three containers you seeing are actually one application combining into one huge application. So they are dependent on one and another. Okay, this is a topic called Docker Compose. Okay, now let's say for any reason, there might be lots of reasons. Suppose for any reason our third container just got killed, or it just died, or it is not working properly. Okay, it is not working properly, it is not receiving any requests or functioning properly. So what will happen? Since all the containers are dependent, your app won't run perfectly. Okay, it will be problematic, right? Or if it is also not dependent on one on each other, still it is a huge problem, cause a huge portion of your system it is not working. So what we have to do? You have to manually go there and manually remove the problematic Docker container and build a new container. Okay, build a new container, set it up, do the configurations and everything. Okay, so as you can see here, it is also a manual intervention. You have to do it manually. It will be time costing. In some cases it can also cost money as well, right? Overall, it is also a huge problem because you can't handle any inefficiencies, any problems created in a container. And having problems in containers in production grade and enterprise level is quite often, because you never know what caused your container to behave like that. Okay, and if you do not take actions instantly, you will lose money, lose benefits. Okay, because the users are not waiting for you to resolve it and then use it, right? So it is a big problem. So yeah, so up until now guys, what have we seen? We have seen some problems of Docker. What are they? I have shown you host resource management. This was a problem. Scaling was a big issue. Then you have seen that load distribution was also a huge problem. And finally you have seen that what can I say, not handling problematic containers. Okay, these are the problems that I have discussed with you, that if you just use Docker and if you are in a production grade environment, when you are using thousands of containers, then this type of problems might occur, and it will occur. Actually, it will occur. So as I mentioned, to resolve these issues, what do? We have this technology called Kubernetes. Okay, so what Kubernetes does is that like let's get to one by one. For host resource management, this one, when you have containers like this, container 1, container 2, container 3, it has an inbuilt capacity or a function or facility, let's say this one, which automatically distributes the um, system capacity or resource. If you are on a system like a laptop with 12 GB, it will automatically assign 4 GBs to each one. Kind of automatic, but also you can have an engineer to do it for you, so that no container exceeds above 4 GB. Okay, no container can go above 4 GB limit. You can do it manually if you have a DevOps engineer in your system. Okay, so it is a facility that you can do resource management very easily. Okay, it can be manual and it also can be automated. So it's a huge plus point. So this was the first problem that gets solved. The second thing is that the scaling part, and it is really important. Kubernetes solves it really easily because it does auto scaling. There is a feature in Kubernetes called auto scaling. Whenever it sees a huge surge of requests or need, it automatically generates extra containers for you to handle the load. And whenever there's less requests, less need of the containers, it just removes them. It is still there, but just removes them. Okay, if it is again in need, it will automatically create containers and handle the situation nicely. So it is a great feature, auto scaling. Okay, awesome feature of Kubernetes. The third thing of the problem that we face with Docker is load distribution. Again, load distribution is also handled by Kubernetes because it has that function called load balancer. Load balancer. It is a tool that handles all the requests. It detects whether any container is idle. Okay, if any container is idle or it is less occupied, it just distributes all the requests to that. If this one is idle, then it will pass the request to this one. If this is too much in burden, it will skip this one, rather go in a less occupied area, less occupied container. So it just balances out all the requests so that the entire system get nicely managed. Okay, so this was load balancer for you. The fourth one that you can see is that not handling problematic containers. It is also an amazing facility of Kubernetes. Like if you have this container number 1, C1, this is C2, this is C3. Now, there might be any problem, as I have mentioned earlier. Suppose this is a problematic one. This is the problematic one, right? So what Kubernetes does is that it automatically removes. You don't need any manual interventions. You don't need any DevOps engineer to do it manually. It is no time consuming. Everything is automated and automatically gets set. The problematic container gets removed, and in that place a new container C4 gets introduced. Okay, there's a concept of rollout. Due to that, the downtime is really less. You just don't feel it. If your system is properly integrated with Kubernetes, then you won't feel any change. Okay, it will run really smooth. You won't even notice the change inside. So this is the facility that Kubernetes provides us. So again, let's look at the problems. I have told you about the host resource management. It deals with it nicely, equally distributes the resources. Scaling, there's automated scaling, up and down scaling, horizontal and vertical scaling. Everything is automated. No cost, no time waste, no manual labor. Load distribution, you just need a tool called load balancer and everything is all right. Not the handling of the problematic containers. If there's any issues with the containers, it automatically gets shut down and a new container is introduced. Not only this, in a production level, Kubernetes has much more to offer, like container networking, the connection between the containers. Okay, there's security. Security is a huge thing. Then you have resourcefulness, how to handle the resources that you have and be always ready. Availability. Okay, availability. Okay, let me, yeah, etc. There are other features. So you can do so much stuffs using this tool called Kubernetes. And it is so easy. You just need an idea of YAML files. All the configurations are used by creating YAML, a simple YAML file. Okay, so this was all the facilities and the answer to the why question of why Kubernetes, why learn this new tool. Okay, as I have mentioned, due to the lackings, the problems of using containerization tool, that is Docker, individually, separately, we need Kubernetes to solve those problems. And honestly, Docker is not a enterprise level tool. It is as simple as that. If you are doing your personal projects, a simple one, you can use Docker to containerize it, push it in the Docker hub. You can use Docker Compose to launch the entire app. Okay, 3-tier, 2-tier app, all are fine. But when you are dealing in enterprise, a production grade level, when you are working with thousands of containers, you can't just waste time, you can't just waste effort, you can't waste any resource. And for that, Kubernetes is a must. Knowing Docker is the prerequisite of Kubernetes, or you can say knowing containers, knowing about containers, the tools, it is a must, because containers are at the really root level. It is about how you manage them, how you handle them. This is where Kubernetes comes. So at the very last, what we can say is that uh, that you can have this container, you can have this container, you can also have this one, and even, I guess, thousands of containers more. Thousands, thousands of containers. But to manage them all, to handle them properly, to make them really efficient and usable in your production, you need something called Kubernetes. Okay, this is Kubernetes, the orchestration tool. So I hope this was easy for you guys. I tried to explain as simple as I can. So if you still didn't understand, don't worry. YouTube is there. I'm not the only one. You can search on the web. There's a huge documentation of Kubernetes. You just can go there and read out the documentation, see the YouTube lectures, whatever there is available in YouTube and etc. Just know that it is a must tool to learn if you want to go in the path of DevOps. So keep on learning, and I'll be keep uploading videos related to Kubernetes in the future as well. So stay tuned. Bye bye.